All right, welcome back. Last time we looked at transforming this function by doing a vertical shift up 2 units. Our original function was y equals x squared, and we shifted it up to this blue graph, y equals x squared plus 2, by adding 2 outside of the function. So we originally had x squared, and then we added 2. And what we saw was that for each x value, when I just look at the original function, that x value is just squared. But when I add 2 after the squaring happens, each of these y values is 2 more than what it was on the black graph. So, 3 is 2 more than 1, and 6 is 2 more than 4. 3 is 2 more than 1, and 6 is 2 more than 4. And in essence, it looks as if the graph y equals x squared was shifted up 2 units. The whole entire parabola just kind of moved up 2 units to be y equals x squared plus 2. And what's great about that is your intuition sort of corresponds with what's happening. You add a bigger number and it's even higher. And the greater that number is that you're adding to the function, the higher it is. And then if I'm adding a lesser number, it's not going to be as high. And if I actually add a negative number, or if you want to say instead of adding a negative, I'm subtracting, in this case 1, it's going to be below where it was before. And the lesser the number is that you're adding, the lower the graph is. And that makes sense. Positive is going up, bigger and bigger. Negative would be going down, lower and lower. The larger that negative number is in absolute value. And, everything is kind of the way you would think it would be. So I'm going to go back to where d is 0, and in fact I'm going to take that out completely. What we're going to investigate is what happens if I add or subtract a number on the inside. So what I'm going to do to start out is just put a c in here and move this value of c around. And so when we were adding on the outside, bigger numbers went up, positive numbers went up, and negative numbers went down. And so with the C, positive numbers go to the left, and negative numbers make it go to the right. That seems a little backwards, right? It's counterintuitive. It isn't doing what you would expect. You kind of would think, well, wait a minute, if I add 1, isn't it going to go to the right one? And no, it goes to the left one. So we're going to play around a little bit with why that's true. And so to do that, I'm going to take out this C for a minute and just call it 1. Right? So this is the formula that I get when I put x plus 1 in for the x on the x squared, y equals x squared function. So if I wanted to actually look at what that formula would be, that would be y equals x plus 1 squared. I add the 1 before I square it. And so to just double check that I have the same thing, here it is, y equals x plus 1 squared. Let me turn that off. And here it is when I do it kind of using function notation, thinking about a transformation. What have you done? You've taken this function g of x, and instead of x, you put x plus 1 in there. All right, so I'm going to take that out. So what I'm going to do to try to sort of figure out what's going on here is I'm going to add another column where I look at the x plus 1 kind of separately. But I'd actually like it to be in the middle here. So what I'm going to do is I'm going to put x plus 1 in this third column, and I'll just do h of x1 over here. And I don't need that, right? I'm just going to look at, okay, our original graph. I'm going to turn this off for just a second, and I'm going to turn that off for just a second, and I'm going to turn that off for just a second. And turn everything off but the original function. So here's y equals g of x. So y equals x squared, and great, I'll put those dots on there. But what we see is if I before I square things, I add 1 to the input. So I'm going to look at, that graph shifted to the left and think about if I'm an x value, like for example, x equals 0, the first thing that happens to me is I get 1 added. So it starts out 0, right? X is 0. 0 plus 1, that's 1. And so G isn't going to be acting on 0. G is going to be acting on 1. So when I'm looking over here, I go, okay, so X is 0, add 1, now it's 1. Then I look for what G does, and G takes 1 to 1. So my output, my original input was 0, then I added 1 to that, and then it got squared, and it's 1. And that tells me what's the y for h of x when x is 0. So I've got this ordered pair 0, 1, which is right there. Right there. Okay, but what is it? It's basically what you get when x is 1 on G. So you're going to have that exact same output for when x is 1 on G, but it happens earlier. It happens when x is 0 for H. Okay, so this ordered pair is as if it moved over to the left, 1 unit, same as this one. So if x is 1, what's the first thing that happens in this function H? First thing that happens if x is 1 is it adds 1 to it, it becomes 2. Okay, so x was 1, but no, it became 2 before it saw where it was going to go. And then in G acts on it, and G of 2, that's 2 squared, that's 4. All right, so now we figured out what H is going to do with input 1. It's going to output 4. And here it is, 1, 4. There it is right there. But that's 1 unit to the left of this point on G, because G doesn't do anything. G just takes an input value like 2 and squares it and gets 4. Right? H, on the other hand, takes an input value like 1, adds 1 to it, figures out what G would do to that, and then plots the point. So feels like that's a little convoluted. I've talked a lot, and whenever a teacher, whenever a professor professes a lot, expect to rewind and re-listen and think about it yourself. But what I'm going to do is I'm just going to put this C in here and let C take control of what happens. So C is 1, shifted over to the left 1. That black graph shifted over to the blue graph by 1 unit. All the ordered pairs are 1 over. And if C were 2, then it would be over 2 units to the left of the black graph. And if C is even bigger than that, it's going to shift even further to the left. And if instead I go the other direction and I subtract a number on the inside, so here I'm adding -1. I'm adding -1 to so this isn't C. Let me make this C so we can see it in the table as well. So if I'm adding -1 to 0 and I got -1, okay, cool. Then I square that and I get 1. The next one, I add -1 or subtract 1 from 1, I get 0. 0 squared, that's 0. Start with x equals 2. Start with x equals 2. Well, what's going to happen to that for the blue graph when x equals 2? Well, first thing is I'll subtract 1 and get 1, and then I'll square it and get 1. So here I am on the blue graph. When x is 2, y is 1. All right. Thank you. I'm absolutely happy if you understand this. Hopefully it doesn't take you too many tries to get the hang of it. Next time, we're going to look at what this might look like if we're trying to get the formula of a linear function.